Excellent. Can everyone hear me okay? Cool, yeah, so standing up here, I can't believe they let me speak at SREcon. I've been an attendee for a few years, and it's always such a great conference. So I gave a variation of this talk at the USENIX Operational Machine Learning Conference in Santa Clara earlier in the year. And I'd really submitted the talk and been there out of despair as someone who'd operated machine learning in production and had encountered all these things that didn't work at all. And I wanted to go in front of the community there and be like, hey, I'm normally from the SRE world. Nothing from there is working, and everything's very rosy in machine learning engineering land is the point. But yeah, someone from SREcon saw the talk and was like, hey, you should expand some of this and submit it. So that's why I'm here today. And that leads nicely into just a brief introduction into who I am. So I spent a big part of my career as a software engineer on a team of data scientists. So if you remember the sort of data science gold rush of 2011 and 12, where everyone had heard that Google uses machine learning like everyone else uses an if statement, and all these companies were like, we want that. Everyone over-indexed on hiring these PhDs and academics, and about a year or so into it, realized that none of this software was going to run itself, and none of these data features they built. And there were people like me who were software engineers who were totally unsuspecting who ended up on these teams, and we had to run it all and get it all into production. As they say, if you find yourself around a poker table and you're not sure who's there to lose all your money, it's you. Around that time, if you were a software engineer and you found yourself surrounded by these wonderfully intelligent and diverse data scientists, and you didn't know why you were there, it was because they were going to give you the pager and make you run everything. Right now, I'm working on some adversarial experimentation tools that allow you to proactively explore failure in your production systems. But what we really do is make really dope stickers and memes. I see a giant camera pointed at me, so the one that's clearly a trademark violation had nothing, wasn't me. So yeah, I'd like to give like a brief rundown of what we're talking about. But what's really important about this talk is really what we're not talking about. I will cover a lot of topics in this talk, and I'll take giant fields of that are very broad with lots of information and boil them down to a single slide just to make them simple. So I'll call out when I do that. But just really the things on the left are the core concepts I'm not talking about in this talk, even though I'm going to talk about them, what we're going to cover in this talk. But it's really the stuff on the right that I want to get to. So we'll frame the stuff on the left. You're the correct audience for it, in order to juxtapose and take them away from you once we do the sort of ontological world building of what all these concepts mean, so that we can leave you in the despair that I was in when I was at the machine learning conference presenting my despair of why I couldn't figure any of this stuff out. So yeah, let's go. Let's talk about all the stuff that this talk is not about, and it's going to take about half the talk. So I just want to set up the core premise at the beginning. So there's these two concepts that go very, very nicely hand in hand, and it's complexity and failure. And as SREs, we're about reliability and robustness of our systems. And it's really these two things hand in hand and direct exposure to failure that allow us to achieve a sense of reliability and robustness. And really, complexity is a side effect of success. Either you've experimented and your business has been successful and you've been trying to find market fit, and now you have all this legacy software that's running, and that's complexity, side effect of success. Or your company's grown very large and you're experiencing Conway's Law, you've got a giant team, and you have what's called essential complexity, and you have to proactively manage and deal with that to continue to move at speed. So there's these two types of complexity, essential and accidental. Just very quickly cover accidental. Accidental is what I mentioned originally. You kind of arrived in this state, and there is some redesign or some way of changing the system such that the accidental complexity can go away. But what we're really interested in, and almost every talk has sort of mentioned this, is essential complexity. So what I want to establish is that the solution to complexity is not simplicity. What we actually have to do is completely embrace and manage complexity. We're all on the same page of that. This is the right audience for it. But there's this other side, which is the other concept that goes hand in hand, which is a core component of complex systems is failure. And when we're talking about failure, what we really mean is that there are these properties of a complex system, and such that they are very hazardous. And what that means is we've added lots of layered components and defenses to the system, and it's the emergent behavior between the interactions of those components that can cause the hazard and thus the catastrophic outages. And a catastrophe in a complex system comes from lots of these small components misbehaving in small ways, not like a single item. And another part of that is that error detection of these types of failure is incredibly difficult because of the emergent and a complex interaction between these components that prevent you from being able to reason about them or anticipate them a priori. So side effect of that is that there's no root cause, but what I really want to drill down to is that as a participant in the system, as an operator, you operate with two roles, namely that of a producer and a defender of the system. And we'll get to this again later. But here's the first thing where I take a whole world of thought and boil it down to something very simple, which you could reject. But what I'd like to say is there's two threats to your availability, and we can model this back to this like dual operator role. One is that the software changes, and I'm talking about software generally, like there could be a config change or just an application change, and that is a threat to your availability. But the other side of it is that you haven't changed anything in the environment in which your application or your services are running changes. And what I mean by that is things like network latency could change, you could have resource contention or a noisy neighbor, and this is a different way that could be a threat to your availability. So we've got two. The whole world can boil down to this binary. It's great, works, right? But yeah, I want to relate that back to what I said about the dual role. So the software changes, you are the producer of the system, and you're participating that way. But when the environment changes, you are a defender, and this is a very different role. And this is the role you take during an incident. You are a defender of the system, not necessarily someone who is producing it. And yeah, this is really what I want to cover, is that this allows you to be a participant in the system during an incident. And the main reason I'm setting this up is so I can take it away from you later. So that's a lot of the stuff we aren't talking about in this talk, even though I've been talking about it. And one of the reasons I'm telling you about this is because I kind of want to propose that a lot of this type of complexity, which is probably why you all came to this talk, I'm sorry, is that we're starting to arrive at a set of tools and vocabulary around complexity that is kind of making it a solved problem. So let's revisit complexity. I'm talking about necessary complexity, and what I mean is the Amazon and Netflix kind. So we've probably all seen this 100 times, maybe. The one on the left is the microservices architecture of Amazon circa 2002 or 3, I think. So who knows what it looks like now. And on the right is a fantastic visualization that Casey Rosenthal always posts, which is when he was managing the traffic engineering team, which was like the flow of requests for your kids playing Super Monsters, but that's what it looks like. And looking at that kind of complexity, like how do you manage that? And this is what I mean when I say, there's a few of these companies that have operated at incredible scale, incredible levels of complexity, and they've sort of outlined this way of managing it all for us. And this is like a really subtle idea, but this is the shift, is you want to start to forgo correctness and adopt safety. And going back to what I was saying about failure in systems, what this really means is recognizing that there's a hazardous sharp edge to your system as a whole, and preparing yourselves for interacting with that sharp edge and providing yourselves with some tooling around that. Again, this is all stuff that this talk is not about. It's just setting things up for you. So we build safety apparatus into the system, and what that really means is humans and culture, but as SREs, we want to know what are the actual things, what is the tooling. So I'm just going to very briefly tear through like 3 concepts that I like to set up as a sort of vocabulary of tooling for thinking about managing production complexity. So I will satisfy some of the promise of this talk of not having incidents and war stories. So these are the 3 concepts I really like to get into, and in combination together provide us with a psychological vocabulary for thinking about managing production complexity. So the first is test in prod. Has everyone heard this? Test in prod? Yeah. I mean, a few years ago, this meant this. It meant this joke, which was a meme, which really meant that you were a cowboy. You didn't test your code, you logged into servers and you changed things and that kind of thing. But what's really happened in the last year and a half, is it's gone from like a meme to a must, largely driven by someone called Charity Majors, who's the CTO of a company called Honeycomb. And what this has really reframed this idea as is that testing in prod, it doesn't mean we just release the software without ever testing it anymore. What we're really talking about is this idea that testing in prod means that we've extended the software development lifecycle beyond release. So when we were talking about complexity, emergent behavior, what that means is that there's all this unknowable, unknown stuff in the production systems at scale that we can't know. We can invest time trying to make perfect staging or replication environments, but really what the test in prod kind of philosophy is saying is actually go to where all those unknowns are and explore them there. And just to quote her, this is really the point that drives it home. It's like real users, real traffic, real scale, real unpredictabilities. So the second concept I mentioned is progressive delivery. Has everyone heard of this one? This one's a little newer. Yeah, okay, so the right audience. So yeah, this is coined by James Governor of RedMonk. And what he says is progressive delivery is continuous delivery with fine-grained control over the blast radius. So a lot of people will contest this definition completely. So isn't that just continuous delivery? And he raises a very good point, which is it's a very subtle, again, mindset shift from just everything continuously happening, which feels to a lot of enterprises and organizations like you've completely lost control of the release process. But what he's really getting at here is actually doing continuous delivery with absolute control. And what the real message of progressive delivery is, separating deploy from release. Because as we know, we're all SREs here, things are definitely going to go wrong. And there's a couple of tools or kind of mechanisms for implementing progressive delivery. The first is feature flags, sorry. So this is where you can target specific users with a particular feature. So you can deploy your code, it's deployed, but then you're controlling the release to specific groups and managing things that way. And toggling things on and off for different users, observing how they respond, that kind of thing. The other tool that's common and was mentioned, I think it's been mentioned multiple times today, and was mentioned as maybe being controlled by ML just previously, was canary deployments. So what this means is you deploy the code, you expose some percentage of live traffic to this canary, and essentially run an A/B test to monitor whether your key business metrics are still performing, improving, getting worse, and then releasing wider once you feel very confident in the quality and the goodness of that release. And then the third tool, which is my favorite, and I haven't heard it mentioned here, funnily enough, today, which is error budgets. There's been lots of talk of SLO, but not much on error budgets. So you read the SRE book and you learn about error budgets as a means for thinking of like reducing alert fatigue and starting to protect yourself and your team psychologically. But one way that error budgets are well framed is really as an opportunity, and an opportunity for learning. And this is really my favorite way of thinking about them. And the idea being that it's not necessarily, or it just isn't your job to create infinitely reliable software. And there's a lot of additional business value that is present in letting the software be kind of broken. Maybe the natural distribution of failure has spared you, but what this means is that if you're thinking about error budgets in this way, you have nines to play with, is what it really means. And the way I like to propose this is that you can permit some Audacity because you have Audacity capital. And what this really means is starting to experiment with your system. Use your sort of availability or error budget overage to try audacious things. So if we think back to my very simple view of the world of you can change the software, you can change the environment, this is where you start to think about, oh, maybe we do something like chaos engineering and start to experiment with the systems and inject things. And because we do have some headroom in our error budget here to play around. So again, this isn't what the talk's about, but it gets us to a nice ontology of thinking about complex systems, avoiding incidents, and a nice tool set and vocabulary of how we deal with that. But what this means is, recognize the sharp edge, and now we have this vocabulary for thinking about safety. And I kind of jumped ahead, but it's essentially this. Experiment with your systems and your complex systems, and you'll be able to safely manage them. So now we can start to get to what I really want to talk about, which you're like, oh, you covered a lot of stuff there really quickly. But what I really want to try and now focus on is the subtle and the oblique. So I mentioned at the beginning that I originally gave this talk from my experience as an accidental machine learning engineer before we knew what those were. And what I found, it was putting models into production, and this is, again, to boil down this idea, like we just had this wonderful talk about machine learning and all this, but us being people who are given things to run and operate in production, to me it's just models in production. You give me a model, customers need to touch it. But what I've found in running these is that a lot of these tools and techniques, even these things that are very modern that I just put in front of you, don't necessarily apply to some of the outages and incidents that we experience with these data-based services. So not a database service, a data-based service. And now I'm going to kind of go into why that is. And not necessarily with any answers for you, I'm afraid, but mostly just to share in the despair. So as you end your first day, you can leave like, oh man, that was terrible. But that's been my life. So what I'm talking about here are models in production, very much an oversimplification. But what we experience with these model-based services is there's latent catastrophic behavior. And what I really want to ask is, what in this case are the failure components? And should we even think of these as outages? My argument is yes, they are outages, but currently we don't consider them outages. They're just kind of like weird stuff that happens with machine learning. So again, now I'll start to tear things down that I built up before. We spoke before about complex systems, and the complexity is necessary, and it's about the interaction between all of these components and safety mechanisms. But what we find when we're deploying models is that we don't have any of that complexity. A model is often just a single artifact. So suddenly you can deploy it, and there's just one thing. It's like we have the LAMP stack again. There's this one thing, but there's lots of complex behavior in how it manages data. So it's the same level of complexity, but there's not all these components. So if I go back to the Amazon or Netflix slide, we don't have any of that. We just have this one thing, and there's requests coming into it, but it's as complex as that. What do we do with that? And the giant threat to us at this point is that data and our input as data is a new vector of failure that none of us have been thinking about as SREs. Someone might put their hand up and be like, oh, actually, yeah, but generally no. So let's revisit my oversimplified binary model of the software changes and the environment changes. And I'm going to add a third one to it. And this is just from experience and my despair, which is, yeah, we've got the software changes, the environment changes. There's now this third one when you're asked to put these models into production, which is that the data was completely unanticipated. And now revisiting what we were saying about complex systems and safety and how things fail, is that the data now becomes a hazard. But yeah, I don't know how to deal with it because we don't have any means or tools or apparatus or any way of thinking about data as a component in a complex system. Like, no one's been thinking about this. It's just a new thing that's happening. So just before I move on, is anyone here from Apple? Noah? Okay, because I wanted to thank you, because I've given this talk a few times and it's been vague, and I've really struggled to give a great example. But there was something a couple of weeks ago, a very specific incident from Apple, that it's like the rug that really ties the room together. So this got written up in all the newspapers. So we're all familiar with this thing. I won't say it, but you sort of say, "Hey, dingus, how old is Bob Dylan?" And basically, it was replying that Bob Dylan had died, in 2008. Okay, so this, maybe this isn't traditionally what you think of as machine learning, but there's obviously a whole bunch. This is what I'm talking about as a data-based service. There's some element of crawling, lots of data input, probably some text extraction, classification, summarization. This is it. So I know we just had a whole talk on machine learning, but I'm going to try and boil down all of machine learning down to one slide. So this is roughly, from me, as an adjacent person to machine learning people or data scientists, how it works. You get a bunch of data, you slice it up, that data is labeled with the answers. You train a model on a bunch of this data by removing the answers and taking some of the pieces of the data and feeding it as features. You then take the output model and compare it to the answers from a different slice of the data. You randomly tweak some knobs that go into the model. You do this until it looks kind of good when you're comparing it to the different samples and slices. You say, awesome. You build and bake an artifact and you deploy it, and then users start touching it. But what we've just shown and demonstrated is that you do all of this, and then your model goes out there and it kills Bob Dylan. So yeah. What I really want to say is this just a bug? Is it a bug? I would say no, necessarily. We treat it as a bug right now. It's like, oh, we killed Bob Dylan, shit. But what's actually happening there is it's not consistently killing legendary icons from the 60s. It's just killed Bob Dylan. So it's not really a bug. I would say, yes, that is an incident, even though we sort of laugh about it and it got written up everywhere. I think we should consider it an incident. And I would actually say we should start to consider these kinds of failures in data-based services or these failures in model-based services as an outage. What I'd subsequently say is that we should call these behavioral outages. And it's really a result of data replacing code. So when I was saying before about how we get something that looks simple but is complex, such that there's just one artifact and we can't draw one of these giant, wonderful maps, it's actually the complexity in how the data is handled internally as a black box that creates that complexity. And yeah, that's the gist of it. So essentially, data complexity has replaced code complexity. I just want to touch on one thing, which I'm probably not perfectly expert to talk about, which is this a gray failure? Gray failure is a concept where something is misbehaving, but your kind of configured fault detectors are unable to recognize in a time window whether it is actually broken. I would say this isn't that. Again, for the similar reason I would say this wasn't a bug, which is that it's, you're not configuring any failure detector to detect murderous behavior in this model, or even then specifically, you're not going to configure anything to say, let's monitor this code and say, is it going to go out and kill Bob Dylan? So I would just sort of sweep aside this idea that this is a gray failure, and this is what we're going to get more into, is like, how do we even begin to think about and monitor this stuff? So yeah, that's that. Here we are. Are any of you in absolute despair with me yet, or not really? So it's like, what am I supposed to do with this stuff? So let's go back to sort of the research and how everyone's thinking about incident management right now. So with a conventional incident of a normal services, it sort of looks a bit like this. Not this, this. Which is this, like a traditional incident, in the middle of it happening, it's got some of these characteristics. It may be slow, it's down, it's kind of intermittently available. And there's these last two that are kind of interesting and do overlap, but it's doing something weird or something else that speaks to it is kind of acting weird. But what's really interesting about this is that, what we're learning about incident management is that you can really reason about what is happening and debug what is happening while it's happening. The system is in some sort of failure state. We're experiencing some emergent behavior. It's hyper complex, but we can get on a bridge, start an incident command, and people can start sharing information and start to debug the incident. And we can then start to instrument, when the business says, like, this should never, ever happen again, and we can be, oh, no, totally. Mark is going to, or Marcus is going to like be on call, and we can instrument this, and it will never happen again. I know that there's probably a whole battle we can have about MTTD and MTTR, but just for the purpose, what I'm trying to say here is we can start to instrument this stuff to make, kind of monitor it going forward in the future. But really, a conventional incident is we can learn and identify what is happening while it's happening. I just want to caveat and say, I'm not saying normal incidents are easy to understand, or that the data is shallow, or there is a root cause. It's really just this that I'm getting at. New data about the system can be gathered while an incident is happening. It's a giant learning opportunity, and it can be circumvented and fixed during the incident. And the other side is the participants in the system, when I said about the dual role, they can actually take part in the incident, learn more about it, and we build actual resilience, which is like team and human resilience around the system as participants in it. I like to show this slide, or this image by Richard Cook from one of his papers, which sort of shows the sort of bias after an incident, but all the things that go into it. And this is what I'm saying. In a normal incident, you have all these angles and mental models that come together, and the more people who are participants in the system can come together and learn about the system and figure it out. What I want to now tear away from you is that we can't do this with these database services. And this is really the gist of the talk, is that with these simple artifacts and the way that these services fail, most of these things that we're used to exploring and using to learn about what has gone wrong are unavailable to us. So even with common ways that we might monitor these services, anything like this could be possible. It's faster, the availability might go up, it's way more stable, and it's handling many more requests. And it's still, the only overlap is that stuff got weird. But what's really interesting is that we can't, because it's the historical lineage of how this data has been prepared and how the model has been trained that produces this single black box that we have deployed. It's completely impossible for us to now generate and learn new knowledge about this outage in this system while the incident is happening. Detecting behavior like this odd behavior is super hard, and the participants of this system are completely excluded from using an incident as a learning opportunity. And this leaves us with this case, which is in a normal incident, we'll be able to learn and mitigate in real time and learn more information about the system. With these database services, there's nothing you can do. Your only hope is to roll back and just hope that you're able to reverse engineer how you got to this endpoint of the black box model and try and reverse engineer it that way. So yeah, I already mentioned this, but what is the metric or dashboard we could build for detecting that our application has killed Bob Dylan? So I'm just going to go into a few examples that don't mention, because I'm recording, I'm not going to mention any companies, but just incidents that have sort of, I've seen in the wild that relate specifically to machine learning engineering that create these kinds of incidents that I think are really difficult to reason about and don't give us much in the way of tooling of how we can begin to mitigate and detect them. So the first is like the it's stable case. So there's this concept in machine learning pipelines and model training called the pipeline jungle. And it sounds kind of like what you'd expect. This idea that there's this whole crazy process that's gone into training and building these models, and like I said, slicing up the data and doing all this training. And what usually happens is that it exists across data scientists' personal machines. What can quite commonly happen is that there's no checks or balances against this being a repeatable process. And what can actually happen, and it was mentioned in the previous talk, is that you can build a model that is out of date with the model of your users that you're trying to make inferences for. And you can simply just deploy a model that is modeled on a business that is no longer yours. It's like an old version of the business. So you're essentially deploying something that doesn't do anything or completely is irrelevant to your current business. Would you call this an incident or an outage? I probably would. If you deployed some code that just did completely the wrong thing, that would definitely be an incident. The second situation I want to get to is where it gets really gets faster. So training a model with incorrectly labeled or unstable data can really train your model where the distribution of the data is incorrect. And what happens then is you deploy an artifact that is trained on some poor data, and new inputs that are coming into the model just get completely ignored. So your response is just ignoring stuff and giving back defaults or something. And what you actually end up with here is that you're monitoring and you're getting faster response times. So you're getting completely the wrong behavior, not actually making inferences, but you're getting great response times from this service. I don't know, inputs ignored. To me, that's an incident for sure, that's an outage, but we don't really consider it that. We're just like, lol, someone deployed the wrong thing or trained with the wrong stuff. Last is stable. This is like a really common one. This is probably what isn't fair to put up here, but like I said, the machine learning engineering world is sort of catching up to where we've been and where we're all grizzly. But it's really common for this to happen. Because the inputs to these models are generally just data, it's really common to see this happen where someone builds and bundles something and the build pipeline is something that's on their machine. And what they essentially do is package up the wrong thing, deploy it, and the wrong thing is in production, but it looks like it's responding to inputs correctly. And this is something where, it's just really stable. It's just not doing anything, but it's the wrong code. Think of it this way. If you deployed something to your checkout service and it was actually refunding everyone the amount instead of charging them, that would be a giant incident. But this happens all the time in this world. The last one I want to get into is just it's faster. It's really common to implement sort of code switching and experimental code paths for different subsections of users when you're deploying some of these services. Think of a recommendation engine, and this is really common, where someone's trying to, for a subset of users, test a different kind of set of inputs and generate a different set of recommendations, and everyone else gets a default or a fallback. Something I've seen happen multiple times is where everyone just gets the default fallback and no recommendations are happening in the system at all. So it sometimes can take weeks or months for anyone to even detect that this has happened or realize that they've deployed the wrong model. So essentially imagine this, you deployed a service and people had worked on all this stuff and it just didn't do anything for a month. Would you call that an incident or an outage? I would. I think we need to reframe this stuff. So yeah, getting towards the end now, but I mean, all the safety mechanisms we did talk about do work for these type of services, but they only really about catching performance regressions. A lot of the world, and there's none of it here yet, but a lot of the world of all these machine learning platforms and pipelines are all focused on this. They're kind of taking what we're all doing as SREs and kind of bundling it up in this really rosy way of here's how you get it into production without needing to call the SREs for data scientists. But what we really need to see happening is that the maturity of the life cycle apply to the data science pipeline and sort of shift left there. So reproducibility and data versioning become hyper important for reverse engineering these outages. The final thing I'd leave you with is it feels like Skynet is here, it's murdering Bob Dylan. It's just stuck in the corner, bumping into the wall. I think, as I said, the modern safety techniques do work for regressions, but I'm unsure what to really begin to monitor and take this to the next level to monitor these things as outages. I think the first step probably is just acknowledging that they are incidents and outages and going from there. But yeah, the catastrophes with machine learning and database services are super weird. And luckily for now, it's all playful stuff. But one day, one of these things really will kill Bob Dylan. So thank you.